Well, stars have a life like human beings. They're born, they grow, they age, and they die. And a particular type of star, very massive stars become neutron stars. So this is a very exotic type of star where matter is extremely dense and compact. So you have the mass of somewhat more than the Sun, but it just has something like 10 kilometers in radius. And so this is an enormous density, has enormous magnetic fields and a number of interesting properties. And sometimes these types of stars are in binary systems, so that they orbit around each other, and while they do this, they emit gravitational waves. Thereby the orbit starts shrinking, and then they start merging. And when they do merge, they probably produce one of the brightest explosions that we see in the universe. And on top of that, in this merging process, they kick out some material. And this material is extremely neutron-rich, because the stars were made nearly entirely out of neutrons. And while this matter is expanding, it undergoes a process of forming new elements.
Basically what we do is we try to model the neutron star mergers using computer simulations, trying to see how this event actually looks like, as if we were there. And we try to see how much matter is ejected, and also what kind of nuclear processes happen in the ejected matter. And it turns out that lots of heavy elements are produced in the so-called R process nucleosynthesis in this neutron star merger ejector. Heavy elements such as gold, platinum, you name it. And in some of the radioactive elements such as uranium and thorium are also produced, and other elements that we don't see anymore because they have already decayed. And in the process of this decay, in the process of radioactive decay, they produce so much energy that you can actually see it in the sky as a flash, as an optical or an infrared transient. So recently, in June this year, there was a relatively bright short gamma ray burst, and astronomers have pointed Hubble telescope to see if they can notice something unusual after the burst. And indeed, they saw an infrared transient, which is actually consistent with what's calculated.
And this is actually a very important result, because it brings really together different areas of physics or astrophysics. On the one hand, one hopes to soon detect directly these gravitational waves, and seeing such a flash as Oleg has just described would be very helpful in getting some confidence that this is really happening due to a neutron star merger. And the other big open question was, where do all these heaviest elements come from? And now it really seems that different pieces of the puzzle just start to fit together very nicely, that we have these very bright cosmic explosions, these gamma ray bursts, that we have the nucleosynthesis happening there, pretty similar to what we have thought would happen. It seems that these transient events due to the radioactive decay make sense. That has also been predicted, so people have worked on this for about a decade or so, and hopefully in the not too far future people will detect gravitational waves, and this could be instrumental to really identifying them.